Hi, so let's continue solving our EndSem question paper. For this video, we are going to solve the question number third. So let's start with the first subpart. Compute mean, median, and mode and standard deviation of a small given data set. Explain when each measure is appropriate. So let's start by a small data set. So in here we have a data set. Our data set values are basically test scores of 9 students. Our data set value includes 75, 72, 85, 90, 78, 85, 92, 68, 85, and 88. First, the mean or average is calculated by summing up all the values and dividing them by the number of observations. So the total sum of all scores is 743, and dividing it by the observations, that is 9, gives us approximately 85.6. So the next measure is median. Median represents the middlemost value of the sorted list after ordering the scores from lowest to highest. So, as in 68, 72, 78, 85, 85 again, 85 again, and then 88, 90 and 92. The fifth value, which is 85, is the median. The mode identifies the value which appears most frequently in the dataset. So, the score 85 appears the most frequently. It appears 3 times and making it our mode. The standard deviation measures how spread out the scores of our are from our mean. So the standard deviation formula is the standard deviation of the dataset approximately 8.4, indicating a moderate level of variability among the students' scores. So it is the summation of each observation minus the value of the average, that is squared and divided by n. And the square root of this entire expression gives us the standard deviation. So now regarding when to use each measure, the mean is most appropriate when data is normally distributed and free of outliers. The median is preferred for skewed data or when outliers are present, as it is less sensitive to extreme values. The mode is useful for identifying the most common values, especially in categorical data sets. The standard deviation helps us understand variability. A high standard deviation would indicate that the data is widely spread, widely scattered values, and when there is low standard deviation, it suggests more consistent data. So these statistics provide a clear and comprehensive summary of the dataset's central tendency and variability. Now let's proceed to the next subpart of our question number three. That is uh, question number three, subpart B. What is the difference between errors and artifacts in data cleaning? Explain any two imputation techniques. So let's proceed to that. Uh, Let us begin by distinguishing between errors and artifacts in the content of data cleaning. In the context of data cleaning, the error refers to data values that are simply incorrect. They may arise from human mistakes such as typing the wrong number, or from the system issues like faulty sensors, missing entries, or duplicate records. Because errors are directly distort the accuracy of the dataset, they must be identified and corrected and replaced, at least replaced, or they must be at least eliminated from our dataset. Artifacts, on the other hand, are unintended patterns that appear in the data not because of something is wrong by the value itself, but because the way that the data was collected or processed. For example, the transformation step may accidentally introduce a recurring pattern, or any instrument may add systemic bias, or artificial artifacts do not represent the true real world behavior, and they are not, if they're not addressed, they can create misleading trends in the analysis. So in short, errors are wrong values, whereas artifacts are false patterns introduced during data processing, during the handling of data. So next we should discuss about the imputation method. So let's move on to the two common imputation techniques used to handle missing data. The first one is mean median imputation. In this method, we replace the missing value with the mean or median of the available observations in the attributes in that particular attribute, meaning that the imputation is typically used when the data is roughly symmetric, while median imputation is preferred when the data is skewed or contains outliers. This approach is simple and efficient, but it does reduce overall variability and can weaken relationships between variables. The second technique is the KNN imputation technique. A value is when a value is missing, we identify the k most similar records based on the other attributes. We can then fill the missing value using the average, median, or a majority value for these neighbors. This method usually produces more realistic imputations because it respects the internal structure of the data set. However, computationally more intensive and sensitive to choice of k. So the scaling of features should be done correctly. These techniques allow us to retain the size and utility of the data set while mitigating this impact of missing data. We can also compare the imputation approaches, because choosing the right imputation approach is often crucial for modeling our situation. It depends from situation to situation, where we can afford more complexity, where we can afford only less complexity, where speed is a major factor, speed is not a major factor. For example, mean median mode calculations are extremely easy, so speed is the fastest in mean median mode. However, the speed for KNN processing is far lower. However, it also provides better accuracy. So this is why choosing a better imputation approach matters. Thank you. We shall solve the fourth question in the next video.